more videos, please click here and subscribe my YouTube channel. Thanks for watching. Hello. Good afternoon. Kay palis na akong himo ni akong presentation karon. Lami sayaw sa ko karayot ha. Anyway, shout out sa akong mga friends throughout the world. And this afternoon, I would like to give you my presentation on the topic. We have quarter 3, module 4, lesson 3, week 4, and we have day 3. Okay, so akong module 4, lesson 1, week 4, D1, musunod kay ako pang gi-edit hinay ang internet. Okay, so fasten your seatbelt now and please do understand this topic. Okay, so we have lesson 3 of quarter 3, module 4, solving problem on permutation and combination of objects. Solving problem on permutation and combination of objects. Hindi ta kayo isayaw eh. Okay. So we have objective. Solve problem on permutation and combination of objects. Lesson 3 again. Objective. Solve problem on permutation and combination of objects. Okay, diretso ta sa what's more or evaluation. Anyway, the discussion on these topics presented during the quarter 3, module 1, 2, and 3. Okay, so we have, in how many ways can you arrange 5 mathematics books, 4 science books, and 3 English books on a shelf such that books of the same subject are kept together? Okay. So in this case, the situation of the problem is permutation. Okay, we have permutation. And we have the solution. Given n is equal to 12, q is equal to 4, p is equal to 5, and r is equal to 3. So we are going to use distinguishable permutation. We have now the number of books total to 12. And we have 5 books, the same, 4 and 3. So we are going to use distinguishable permutation formula. So we have now 479,001,600 for 12 factorial over. The factorial of 5 is 120. Then we have 4 is 24 and 3 is 6. So multiplying 120 by 24 and 6, we have 17,280. And that we have 479,001,600 divided by 17,280 is equal to 27,720 ways. So you can arrange the books in 27,720 ways. So the answer of number 1 is permutation and 27,720 ways. Number 2, in a gathering, the host makes sure that each guest shakes hands with everyone else. If there are 25 guests, how many handshakes will be done? Again, in gathering, the host makes sure that each guest shakes hands with everyone else. If there are 25 guests, how many handshakes will be done? So we have given n is equal to 25. So you are going to use permutation again. So they have now n factorial is equal to 25 factorial. So equals 25 times 24 times ... to 1 factorial. So the answer is 1.55112100433 exponent of 25. Okay. So we have 1.5511121100433. We have exponent of 25. So we have the answer of number 2 is permutation. We have 1.55122100433 exponent of 25. Let's go to the assessment of module 3. Number 1. Suppose you are the owner of a sari-sari store and you want to put 12 pieces of canned goods in a row of shelf. If there are 3 identical cans of meatloaf, 4 identical cans of tomato sauce, 2 identical cans of sardines, and 3 identical cans of corned beef, in how many different ways can you display these goods? Again, suppose you are the owner of sari-sari store and you want to put on the shelf. If there are 3 identical cans of meatloaf, 4 identical cans of tomato sauce, 2 identical cans of sardines, and 3 identical cans of corned beef, in how many ways or how many different ways can you display these goods? So the answer here is there is no answer. Okay? So the answer here is anyway. Okay. So there is no answer. We have number 2. Evaluate permutation of 9 objects taken 3 at a time over permutation of 7 objects taken 5 at a time. So you are going to process first the numerator, next the denominator, and you are going to divide numerator by the denominator, and the answer is 0.2. The answer is 1/5. Number 3. Find the number of circular permutations of 5 people. The answer is 120. Mother and father and 4 children stand in a circle. In how many ways can they arrange themselves if mother and father stand opposite each other? So the answer is, or the possible answer here is 36. Number 5. At fashion show, 5 evening gowns and 5 formal dresses are paraded in a circle by 10 models for judging. In how many different ways may the outfits be arranged if the evening gown and formal dress alternate? Possible answer here is 2088. Anyway, kindly check this in your calculator. Number 5. How many different committees consisting of 3 males and 2 females may be formed from 6 males and 6 females? So the possible answer here is 120. For item number 7 to 10, refer the situation below. Al, June, Nora, Cora, Lynn, and Cassie are members of the group from which the committee of 3 is to be chosen. How many committees can be formed if numbers, there is no restriction? The answer here is, or the possible answer here is 20. The possible answer here is 20. Number 8. Al must be included. Still, Al is included. So the answer here is 20. Number 9. June is excluded. So June is excluded. So there are only 5. Taken 3 at a time. So we have the possible answer here is 10. Anyway, again, check this with your calculator. Number 10. Al and June are excluded. So there are only 4 people left because Al and June are excluded. So the possible answer here is 4. Again, kindly check this with your calculator. Summative. The summative is coming from module 3 and 4. So you have module 3 and 4. So you have 1. How many words can be formed using all letters of the word mass? Again, how many words can be formed using all letters of the word mass? So in this case, this is distinguishable permutation, but there is no alike letter. So this is just the same as permutation of n factorial. So we have now 1, 2, 3, 4 factorial is equal to 24. Again, check this with your calculator. Number 2. In how many ways can 8 people be seated around circular table if 2 of them insist on sitting beside each other? So we have 8 people, and there are 2 people insist to sit beside each other. So this is equivalent to 7 people already. And this is 7 factorial is equal to 5,040. Again, the possible answer here is 5,040. Number 3. The product of a positive integer and all positive integers less than is called as n factorial. So we have n factorial. Number 4. 2 different arrangement of objects where some of them are identical. 2 different arrangement of objects where some of them are identical. So what kind of permutation is that? We have now distinguishable permutation is the possible answer. Number 5. There are 20 men in the chorus of an opera. Half of them must wear long baggy pants, 1/4 long straight pants, and the rest short pants. How many different ways may the pants allocated to the men? The answer is 20 factorial over 10 factorial times 5 factorial times 5 factorial. Number 6. Find the number of distinguishable permutations of the digits of the number 348,838. So how many 3 are there? So we have 2 3s. And how many 4? Only 1. And how many 8? We have 3 8s. So we have distinguishable permutation. This is 6 factorial over 3 factorial times 2 factorial. 3, 4, 8, and 2, 4. 3. So the possible answer here is 60. The possible answer here is A, 60. Number 7. In how many ways can you arrange 8 figurines on a shelf? In how many ways can you arrange 8 figurines on a shelf? Possible answer here is letter C, 40,320. Again, check this with your calculator. Number 8. A spinner is divided into 4 equal parts. In how many different ways can you arrange the 4 suits in the spinner? A spinner is divided into 4 equal parts. In how many different ways can you arrange the 4 suits in the spinner? So your possible answer here is letter A, 6. So 4 minus 1 is 3. 3 factorial is 3 times 2 times 1 is equal to 6. Number 9. If you have 8 chips where 2 are yellow, 4 are green, 1 is blue, and 1 is red. And how many different ways can you arrange the chips in a row? So we have 2 plus 4 plus 1 plus 1 is equal to 8. So we have 8 chips. We have 2 yellow, 4 green, 1 blue, and 1 red. So you're going to use distinguishable permutation. And this is 8 factorial over 2 factorial times 4 factorial. So when you check this with your calculator, the answer is 840. So 840. Close answer there is letter A, 480. But the correct answer here is 840. After solving this using distinguishable permutation. Number 10. How many distinguishable permutations are possible with all the letters of the word ellipses? How many distinguishable permutations are possible with all the letters of the word ellipses? So they have, using the distinguishable permutation, the possible answer here is 5,400. So how many letters has the word ellipses? We have 1, 2, 3, 4, 5, 6, 7, 8 divided by, we have 2 for E, 2 for L, and 2 for S. So we have now 8 factorial divided by 2 factorial times 2 factorial times 2 factorial. Then after solving this with your calculator, we have 5,040 is the possible answer. Number 11. There are 5 letters in the word heart. In how many ways can we arrange all these letters? So the heart has 5 letters and there is no identical letter. So this will be 5 factorial and the possible answer here is 120. Again, check this with your calculator. Number 12. How many different ways may the vertices of a regular pentagon be named with the letters? How many different ways can the vertices of a regular pentagon be named with the letters? We have regular pentagon. So this will be, the possible answer here is 10. Number 13. Suppose an identical twin, 1 identical triplets, and 2 other children pose for a photograph. How many photographs will be different? Assume that the identical twins and the triplets cannot be distinguished from each other. So we have the possible answer here is 420. Number 14. How many 3-letter words can be formed from the word love if its word begins and ends with a vowel. So we have now 4. Possible answer here is 4. Number 15, evaluate permutation of 13 objects taken 3 at a time. The answer here is 1,716. The close answer here is letter D, but there is no 6. So no answer. The answer is 1,716 ways. So it's the end of my presentation, and just hope to those who are not yet subscribed in my YouTube channel, please subscribe, and please do not forget to hit the notification bell for some updates of my video. This is your teacher, Pastor Ayuban. Bye-bye, babu.